Hello, nice to meet you. Nice presentation. I have just one question. Can I use it for a use case of mine where I have confidential data stored somewhere else, but I want to orchestrate my pipeline on a Kubernetes cluster that has no access whatsoever to the data that are confidential and stored near a single machine that can do anonymization of the data, something like that. That was something very cool happened in Paris during the KubeCon, where I had the presentation about interLink. It was the first case where someone talked about a tool that I'm working with daily with a different perspective. In this case was about something like this. So we can take the schema here and say, okay, let's say that I have my Kubernetes cluster somewhere, and then I have here instead a machine, right? This is a virtual machine if you want, and I want somehow to access the data that are here. Okay, these data here are let's do this way. Data here are data that are confidential data. So all in all, what I have here, if you want, we can put this in this way. We have a system that is separate and inaccessible through normal Kubernetes cluster. So my Kubernetes cluster should find a way to go here and say, ooh, cool stuff. I want to send here my a payload of mine. So that does stuff in here, read possibly data from me, from the confidential storage, and then it can do two things. So it could eventually communicate with a service that is on the edge of this machine, of this system that is isolated from my cluster, and say, okay, these are the data that now can be accessed because are not confidential anymore, so I have no sensitive data. And or in another scenario, I want just to behave like a normal pod and bring back information that can be either data to be stored on a different storage system once not confidential anymore, and once preprocessed, or I don't know. So returning, for example, here I can have my GPU, and the GPU can elaborate and do some training, and I want to report the training results in my, I don't know, here I can have an ML flow tracking server, right? So I can create a model, a machine learning model here, and store it somewhere else. So I can train on confidential data, and then I store the results somewhere else. So these are all the scenarios that are going to be enabled by the tool that I'm going to show you today. And so this is the plan. We start with here, we create in just a few seconds a complete plain Kubernetes cluster based on Civo Cloud, civo.com. So we start from here, and then on top of this, we install a tool that is called interLink. That is the one that I presented and I received the use case for at the last KubeCon. So Civo plus interLink will allow essentially as a virtual kubelet to start from here and do this delegation. So this delegation part, sending a pod to run on a remote machine that is not part of the cluster, will be the target for the demo today. All right, how much it takes to do this, to transform? In other words, what we are doing here is taking a pod, okay, This is a pod that I define inside my Kubernetes cluster, and through something magic in here, transform it into a container. Here is a container that is running on a remote VM that is not part of Kubernetes cluster. So here you have a barrier. That's cool. Very cool use case for interLink. Let's take a look how you can search for instruction to reproduce the demo, the today demo. So first thing first, here it is the yeah. So first thing first, let's take a look how you can search for interLink. Simple like searching for interLink intertwin EU. That is the project. You can find all the details here, but basically you should go and see for the GitHub page of interLink. You have all the instructions and more than what you need. You can start going in the guide page and do deploy interLink virtual node. What we are going to do essentially is first thing instantiating a Kubernetes cluster through Cibo. And to do that, to have something to install our interLink into it, we need to create a cluster. I will use this that it takes already everything running, but if you want to see again, I had already a previous video. You can create stuff on Cibo, but it's simple like creating a test cluster, indicating, I don't know, 2 nodes. Extra small is for just for test right now. You can set up a firewall, whatever, and you can install many applications on the go. So for this test, we need nothing. So we are going to take a plain Kubernetes, remove also the ingress part. We do not need the ingress part, the traffic. So we just need plain Kubernetes cluster, and that's all. So you start, you create, sorry for jumping back and forth, but okay. So now we are creating our cluster. Maybe I haven't refreshed the page. No, okay, it worked. So it will take, you see, under 120 seconds to bootstrap. And after this time, you will be prompt with something like that, like this, where you can click on your cluster. Yeah, that's fault of my connection, sorry. You can click and download a complete kubeconfig. What you get from that is something that you can export and see the nodes that you created. So we have a K3s server plain with nothing running on that. So if we need get pod minus, yeah, that's all. Now the other thing that we have a machine dedicated where I just installed Docker. We have a machine with a public IP and on a on-prem instance at INFN. And the cool thing is that if we go back to our schema, what we need from the perspective of the green part here is just an open port, okay, where we are going to set up a service that is listening for information from the virtual node. So this port in our case will be the 3040 443, if I remember correctly. So we created a rule in the firewall to allow this port to be reachable from our Kubernetes cluster. All right, so cool. Now we are going to do our tricks. You have the complete, if you go through the documentation, you have the complete setup, but all in all, it's just a matter of creating a Kubernetes cluster and creating a config map. A config file where you say the endpoint I want to reach and to send my virtual pod is this address, and we are going to take the one of the machine that we just created, and then we go and we have 3443 port open. We select, please remember to select the latest release that you find here, and yeah, namespace with the amount of resources that you want your node to appear with, and the authentication, because again, coming to this map, you can see that here you don't have only a port, but this is where you need to put some authentication mechanism. And what we are going to use usually is an OpenID Connect token or a GitHub one, right? So OpenID Connect or GitHub. In the guide, and what we are going to do is using a client for GitHub, and yeah, the installation script is going to set up everything for us. So you go to the latest release, you download the installation script that you need for your architecture, and you compile a config file that looks like this. You have the address that is this one, and it comes from our on-premise service. And then you have an interLink port, a version that is pointing to the last one, the name of the virtual node that you want to appear on your cluster, and you'll leave everything more or less as for instructions, but you need to pass some client ID and secrets and a username. Once you have this in place, you can say, okay, let's start installing Opla. What happened? Come on. Okay. This is something that, oops. Settings. Sorry. That was the first time that makes this. So security. So maybe it's useful for you as well. Allow anyway. Okay. So now it should work. Open. Yeah, I don't know. And then you copy the code. You follow basically the instruction. We copy the code here. We say, all right, that's all good. Go back. Wait for the creation of all the scripts that you're going to need. Now everything should be as simple as say, okay, I want my manifest to be installed on my cluster, and you should be able to see a pod starting on the namespace that you indicated, and magically, well, not magically, but it can look like it, you should be able to see get node. Exactly. So you have now a new node appearing on your cluster, and sorry, okay, so MySQL node. Now we can take the logs. Oops. Of the interTwin virtual kubelet here, and you can see that everything started, but now it's struggling to contact our remote counterpart. So what we did right now was we instantiate everything on this side. So this is done. Now we want to install all the needed steps on the remote server. And to do this, you essentially have to, if we go back to the instructions that we received, oh yeah, it tells copy the interlink remote sh to the server and do what you need to do. So start everything. We do oops as needed. So scp manifest interlink remote sh into the home of this machine, and then we go to this machine and say okay, go and clear. Good. So we are inside this machine, the remote machine, where in principle we can have sensitive data, and we can mount, for example, we are going to make the data okay, and then we are going to make we are making interlink remote sh executable, and say okay, install things. So it's going to install all the needed stuff, the TLS key and whatever. Okay, well, let's see. Create a certificate for the authentication and so on and so forth. So everything is set up. And if we do, again, remember, I'm following by memory all the steps that are suggested in the guide, so you can find everything here. And if you do start, to process should start immediately. And to take a look at the log, if everything works fine, you should look at logs, interlink log. Okay, so this is running, and also the auth2 proxy is running. Perfect. Now, if we go back to the log of the Kubernetes cluster part, pinging is not erroring anymore, right? So we are good. The communication between the two parts is working pretty good. Now we missed one piece. So to be correct, we are going to zoom what is happening in here. So, sorry. If we are taking everything that is happening here and we zoom, we have the OAuth 2 proxy here that is forwarding the request to a guy here that is an API server, and then is going to go to the person that knows how to run Docker containers on the host, on the remote host. And this one is what we call either plugin or sidecar. In the guide, you're going to find both name for this part, okay? Sidecar. Yeah. So this is what we are setting up on our host. We just need the Docker sidecar plugin. And then we are ready to go. To do that, we simply import a Docker plugin that, if I remember correctly, I should be able. Okay. I can install from here. So there is a link. Oops, in the documentation. Here you see remote Docker execution. We have different backends. Interlink, you can use also batch system in a similar manner, but let's assume that your remote server is a single server where you really want to do just this. So you want just to take a VM with access to confident data and send data back or to an external service. So, okay, so we can take the link from here and do -o Docker plugin exec. So x Docker plugin exec, and all right, so it's asking us to pass a config map, a config file again, sorry, and thing that we can do with this. So interlink config path, and we're going to point to config interlink config.yaml. Okay, cool. Let's see if it's going to work. We have this plugin enabled, and so we have these pieces all waiting for information coming from our Kubernetes cluster. So from the pod that we are going to instantiate and to delegate to our virtual node. And so let's do exactly this. Remember, we have now on our cluster a node that is called mySQL node, and I can assign pods to this node. How can I do that? Again, you can take a look at the examples that we have. Copy this example pod, vim test pod.yaml. You can insert this. You can call it exactly like you want. The important things are the node selector here. Here is a simple busybox that is going to run on the remote side. Next episode we are going to set up exactly what we meant. So right now we are testing things up for all the chain, and once validated we are going to put, for example, a min.io server on the remote server, accessible only from inside, and the training on this data will go back to an MLflow tracking server that it can be either exposed by the confidential server or a remote one. So it depends on how you want to put in place guardrails, basically. But in principle, you can implement all of the security check that you want. You are open to everything. The important enabling factor here is that now you can have a cluster on the cloud, on any cloud provider, and send pod payloads to your confidential server. That's all tracked, all authenticated through OpenID Connect. You can go deeper in the fine-grained authentication authorization stuff, but yeah, that is how cool it is, all this stuff here. And all right, and then you want to put toleration, because by default you cannot schedule stuff on these special nodes. So now we have this. If everything went well, kubectl apply minus f test pod, my test pod. Okay, you see that my pod is running with this ID, and in fact, if I go here, I saw that my pod started and it is completed. And yeah, if we break everything here, we can see that the container ran, so the whole chain of the test actually worked. So let's try to summarize. Would you? So we started from a Kubernetes cluster spawned on sivo.com. On Sivo in under 20 seconds, right? And after that, you got 3 nodes, 1, 2, and 3. No, 2 nodes. You, with interLink, decided to instantiate third one. So now whatever pod you put on top of this will be immediately sent. Okay, from here it will immediately send out a request to some box. Okay, this box can be anything, can be a Slurm cluster where you can submit jobs, and this is useful for HPC, for instance. Supercomputers, you can integrate Sivo cluster with supercomputers, or in our use case, this can be something where you have your data that is only accessible from inside this box, and you take this pod, you take this pod, come on, take this pod, you send it here like a container, okay, and you do whatever you want. Within this whatever you want, there is of course what you can call confidential computing. So there are a lot of caveats and stuff that you might want to decide, and the most important one is that somehow at this level you want to put the guardrails, right? So since this is confidential computing, you should implement at this level something that checks what this container can do or cannot do. So reading data, where you put data afterwards, it's all open, and we are going to see an example on the next video. So if you want to follow up, please subscribe so you can be alerted. Yeah, so but thanks to interLink, to this guy here, you have the whole chain covered, so you can play with all this stuff as you want. In really 5-10 minutes you can extend your Sivo cloud over your confidential data and do whatever you want. Afterwards, the power of this solution is that afterward, if you have now data that are not confidential anymore, you can go back to your Sivo cluster, instantiate, I don't know, Kubeflow or Jupyter Lab or whatever. So you can instantiate your Jupyter Lab here now and do data science. right? So this is the idea. You pre-process data on a remote system, and then you have public data accessible through a normal Kubernetes cluster. So that was all for today. We really just scratched the surface. Next time we're going deeper into this with a real world example. And even more, we are going to see what happens where you have not a remote confidential part, but you have a supercomputer at your disposal that will integrate with a Kubernetes cluster. So stay tuned and thank you for watching.